Hi, so we have a bicyclist problem, and this guy is riding his 10.3 kilogram bicycle with a speed of 14.7 meters per second. So how much? So part A is asking how much work must be done by the brakes in order to bring the bike and the rider to a stop. Okay, so let's figure out the combined mass because this is the bike and the rider. So the combined mass is just 60 plus 10.3, so it's just 70.3 kilograms. All right. Okay, now let's figure out what this person's kinetic energy is because we have to bring kinetic energy down to a zero in order to stop this person. So that because kinetic energy is basically mv squared over r. I mean 2 mv squared over 2. So which means velocity must be 0. So that makes kinetic energy 0. So we're gonna have to bring this guy to 0 kinetic energy. Okay. So we know that our m. So right now, when he's traveling at 14.7 meters per second, his kinetic energy is mass times velocity squared. So I'm just gonna round for now, but I'm gonna use real numbers in calculating. So this is 15 over 2. And that's going to equal to, when we calculate it, 70.3. I'm using real numbers here. So 70.3 times, oh, this is 15 squared. So I'm going to do that twice. So times 14.7, because I'm using real numbers, I just rounded here. Times 14.7. And then that all divided by 2 is equal to 7596. 96 joules, or 7.596 joules, or kilojoules. I mean kilojoules. So, if you got a different answer than this, then you might have a different number. You might have different numbers for the red letters here, and same here. Okay. Now let's look at part B. Well, the part B says how far does the bicycle travel if it takes 3.9 seconds to come to rest? Well, part B takes into account of time, so that might make things a little bit more complicated, but it's still doable. So let's see. So we know that work is equal to force times distance, right? And we're trying to solve for distance, but we know our work because this is the work is just this, or actually this has to be negative because the bike is moving this way, and since you're moving this way, you're trying to cancel out with the bike. You have to do this one. You have to negative it to cancel it out. So anyway, work is equal to force times distance, right? And work is this. So this is work. And what do we know about force? Well, we know that force equals mass times acceleration. Okay. Well, what do we know about acceleration? Well, we know that acceleration is equal to v minus v naught over t, and there's our time. So let's substitute this into here and see what we get. So if we do that, then we get F is equal to mass times v minus v naught all over t, because we just multiplied by acceleration. So if you substitute or distribute that out, you would just get that, but you would just get like mv minus mv naught over t. Alright, so now we have our force. Let's substitute that into here. Okay, so we get W, or our work, is equal to mass times v minus v naught over t times d. T times d. Okay, now let's try to, because it's asking for how far does the bicycle travel, let's just solve for d. Okay, so if we solve for d, we multiply t on each side, so we get work times t, and then you divide by mv minus v naught, whatever that is. So m times v minus v naught, and that's going to equal to d. So basically, you could have just multiplied by the reciprocal on each side, or just multiply by t on each side and divide by mv minus v naught, and basically you'll end up with the same result as this as d. Okay, now let's plug in our values and see what we get. Okay, so for work, and I'm gonna round here. So for our work, we have 7,600 joules. Okay, times t, time, which is 3.9, and our mass, which is 70.3. We defined that earlier, so 70.3 times v, and we have here, because he's already writing, this is I mean, this is initial, so this is negative actually, and v final is final, so this is going to be actually going to be negative. So negative, so v is 0, so this is going to be, it's just going to be negative 14.7, and that's going to equal to our d, which is our which is equal to, let's see, I'm just going to do 76, more like 7596, because I rounded here, times 3.9 divided by 70.3 divided by negative 14.7, and we all know it's negative, so I'm just going to divide by 14.7, and we get 28.67 meters. But if you think about it, if the person is going this way, then you're gonna go positive 28.67 meters, not negative this way, you know. So the answer is gonna be just 28.67 meters. So let me draw a better square. So there we go. So 28.67 meters for me. You might get a different answer. Okay. Now let's look at part C. And the part C is asking, what is the magnitude of the braking force? Well, all we have to do is plug it into the equation here. So let's go ahead and do that. Well, we have our mass of 70.3, and then times v minus v naught, which is negative 14.7, over time. Oh, where'd it go? Oh, whoa, what's going on? Hang on. Let me bring this back. Okay, I guess I can't bring that back. Well, I'll just copy it again then. Okay, so 7, that divide by 3.9, which is time. And that is going to give us a value. Let's actually go ahead and do that. So 70.3 times 14 points, because it's asking for magnitude, I'm going to ignore all negatives, and then divide by 3.9, and we get 265 newtons as force. So that is going to be our braking force. Alright, so that is how you solve this bicyclist problem.